Hello everyone, I'm Sumit from 𝗟𝗲𝗃𝗃𝗹𝗶. So in this video we are going to upsolve the questions from previous CodeChef contest named Starters 175. So yeah, let's start solving the problems.
Now coming to the first problem. So you need to submit the assignment and there will be a deadline for assignment. So the deadline for the assignment is in Y days and it takes you X days to complete the assignment. So you should be determining whether you can finish the assignment or not before the deadline. So if you can finish the assignment, you can print yes. If not, you can print no. So X tells you the number of days to complete the assignment and Y is the number of days left for the deadline. So how to solve this problem? If you see the sample 1 input, it takes 1 day to complete the assignment and there are 2 days left for the deadline. So you can simply print yes. So the logic for this problem will be, if first let's take the values of x and y. See x and y. So the logic is very simple. If the value of x, that is number of days to complete the assignment, is less than or equal to number of days left for the deadline, then you can simply print yes. Right? Else you can simply print no as your output. Okay, so yeah, let's run this and see. The output can be in any format, can be or uppercase characters or lowercase characters, it doesn't matter. Done. Yeah, this is all about the first problem. Now let's move to the next problem. Now coming to the second problem. So basically you're standing in a queue that is infinitely long and you're waiting for the tickets for various events during the techniques. So the ticket distribution follows these rules. So the rules are, for every second the tickets are given to the first person and a third person standing in a queue. Okay, so after receiving their tickets, those people leave the queue and the person who was originally in the second position, whereas before the first and third person leave, so he comes to the first position and so on. So this process repeats for every second with the first and third person receiving the tickets and they will be leaving the queue. So you have given n, which tells you that the position you're standing in a queue. You should simply determine how many seconds, after how many seconds you will get the ticket. Okay, so I have the problem statement is clear. Now coming to the input format, the first line of input will contain a single integer t, denoting the number of test cases. Next line contains n, which tells you the position in which you are standing in a queue. Output format, you just need to print the number of seconds taken to get a ticket for you by standing in a queue. Okay, let's understand a pattern behind this problem statement. So let's observe what is happening in the given input and output format. So the first test case tells you that you're standing in a first position. So if you're standing in a queue, let's say this is an infinite long queue and you are at the first position. You are at the first position. So in the first second or in the every second, you will be getting a ticket, right? First you'll be getting a ticket. Next, here is a person 2, here is a person 3, person 4, 5, 6, 7, and so on. Now, in the first second, you and the third person will be getting the ticket. So, in how many seconds you got a ticket? In 1 second. Similarly, let's see this input for 4. Let's say if you're standing at the fourth position, after how many seconds you can get a ticket? So, simple, it's very simple. So, we are finding the number of seconds taken to get a ticket for the fourth person. So in the first second, person 1, person 3 will be getting the ticket. So in the first second, person 1 and person 3 will be getting the ticket. Now in the next second, how will your queue look like? Your queue will be simply the second person will be coming to the first, then 2, 4, 5, 6, 7, so on. In the next second, person 2, person 5 will be getting the ticket. In the next second, what will happen? 2 and 5 will go, and 4, 6, 7, so on. So in the third second, person 4 and person 7 will be getting the ticket. That means if a person is standing at fourth position, he will be getting the ticket at third second. So after 3 seconds, he'll be getting the ticket. So you'll be printing 3 for 4. So if you observe this, the output for 4 will be 3 seconds. Okay, so let's observe a pattern here. If you observe carefully, let me write the pattern over here. So for person 1 and for person 3, he's getting a ticket at 1 second. For person 2, for person 5, he's getting a ticket of 2 seconds. For person 4, for person 7, he's getting a ticket at 3. Right? Similarly, for person 6 and for person 9, he'll be getting a ticket at 4. Do you find any pattern here? If you observe carefully, if a number is falling under this line, it will take how many seconds for it? Can I simply say it as 1 by 2 plus 1 will give you 1 second? Because as of now we are focusing on these numbers. We're just trying to identify the pattern. Next, 2 by 2 plus 1 is 2. 4 by 2 plus 1 is 3. 6 by 2 plus 1 is 4. So by now I hope you got the logic for this. Now let's see for this numbers as well. If you observe, these are the even numbers and these are the odd numbers, and for one we can separately handle it in the if condition. So if the number is odd, what will you do? Can I simply say we'll be doing 3 by 2, which is 1.5, and it will be converted into integer and it will be 1. Next, 5 by 2 will be 2.5. Integer will ignore the decimal parts. It will be 2. Next, 7 by 2 will be 3.5, which is equal to 3. 9 by 2 will be 4.5, which is equal to 4. So pretty straightforward pattern that we have observed here, which is if the value of, let us consider this as value n. So if n is an even number, if n modulo 2 is equal to 0, or if the value of n is equal to 1, what will you do? You will be simply printing the value whatever you'll be getting by n by 2 plus 1. Else, if the number doesn't fall under this condition, you'll be simply printing the value of n by 2. That's it. This is your code. Okay, so no need to handle a case for 0 because according to the constraints, the value of n can be either 1 to some positive value. Okay, let's convert this logic into code. So if you observe the constraints for this is the value of n will not be less than 1. So there is no possibility of getting 0 over here. So let's start writing a code. First we'll be taking the input for test cases. Then we'll be iterating for t number of times. Then we'll be taking s as input and c as. Now, what was the logic that we have found? If s mod 2 is equal to 0, I mean, if it is an even number, what will you print? You will be simply printing s by 2 plus 1. Next line. Then else, you'll be simply printing s by 2. Next line. Okay, let's run it and see what will be your output. So if you observe, for the first test case, instead of getting 1, what do you got? 0. 1. It is falling under the odd case. So you need to handle it for value 1. So let us submit the code and see. Done. So yeah, this is all about the Second problem. Now let's move to the next problem. Now coming to the third problem, make sale. So you're given three binary strings S1, S2, S3. Binary strings are nothing but strings which contains characters, zeros and ones. So each of length n, that means all three strings will be of same size. Now our goal is to make each string contain identical characters. It can be all zeros or it can be all ones. So to achieve this, we can perform few set of operations. So one of the operation you should do is you can choose x, y from 1 to 3. So that means you can choose any two numbers in the range of 1, 2, 3. Okay, let's say the value of x that we have selected is 1. The value of y we can select it is 3. Now we need to choose indices ij such that the value of ij should be in the range of 0 to n minus 1. Should be in the range of string size. So basically 0 to n minus 1. Once we have chosen two indices ij, we can swap sxi and syj. That means let's say you have chosen x as 1 and you have chosen y as 3. So you will be swapping s1 of I with s3 of j. Okay, so we need to find minimum number of operations required to make each string contain identical characters. If it is not possible to make the strings identical, then we can simply print -1. Okay, so this is all about the problem statement. You are given t number of test cases, you are given the size of the string, and you are given three strings of size n. And in the output, you should be printing minimum number of steps or minimum number of operations taken to convert the strings to identical. If it is already identical string, then you can simply print 0. If it is impossible to make it identical, then you can print -1. Okay, let's understand this problem in a detailed way by taking few examples. Now coming to the first test case, let us figure out, is it possible to make the strings identical? So identical means either your string can be containing all zeros or it can contain all ones. And if your string is containing, let's say 001 or 101, these are not an identical strings. Only these are identical strings. Okay, now keeping this property in mind, let us test, can we make these identical in any number of steps? It's impossible because the values of count of zeros and count of ones is not matching the property. And what should be that property? Observe carefully. Here it's impossible. So here it's impossible. So the output will be -1. We'll understand why is it not impossible once we see this test case. But is this possible? Yes, it is possible. But how can I make it to possible? How can I make the strings to identical? By that too by minimum number of operations. So I can choose I can choose the first index or zeroth index. Let me write the indices here 0, 1, 2. So I can choose the zeroth index in S1 and zeroth index in S3. I will simply swap the numbers. So it will be 0, it will be 1. Okay, this is one operation. Next operation, I can choose zeroth index in S2. I can choose first index in S3. I can swap these two. So this will be 0 and this will be 1. So after making two operations, we made the strings identical. So for this, the output will be 2. So do you understand why is it impossible for this? Yes, because the count of ones and count of zeros are not following the property. We'll figure out that property later. Let's see for the next test case n equal to 4. And for this also, it is impossible to convert the strings to identical. So the output for this will be -1. Coming to this fourth test case, it's clearly possible to convert all the strings to identical strings. But how and why? Because the count of one is 4. Count of 1 is 4 and the count of 2 count of 0 is 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if I want to make a string identical for a string of size 4, it can either contain 4 zeros, it should either contain 4 ones. But in total, if you have only 3 ones, is it possible to achieve this? Impossible. So this is the property. If the count of 1 is divisible by 4, also the count of zeros should also be divisible by 4. Only then we can make the strings identical. Obviously, if count of 1 is divisible by 4, then the leftover values will be only zeros, and even those will also be divisible by 4. Yes. So yeah, this is one of the condition that we can figure out. Now, if once we get this condition, it will be easy for us to check, is it possible to make the strings identical or not. So we will be counting number of ones, number of zeros. Let's say I am storing it in C1. So if you divide it by 4, and if it is not equal to 0, I can simply print -1. No need to check for minimum number of operations. It's impossible, right? So we have figured out when to print -1. Now let us continue. For test case 5, how many minimum number of operations it will take? Before that, how many minimum number of operations it will take? So to get the minimum number of operations, do we need to focus on swapping zeros, or do we need to focus on swapping ones? Obviously ones, but why? Because the count of 1 is less than count of 0. So obviously the swaps taken to swap these ones to make the string identical with ones, so will be less than the operations taken to convert the strings to 0. Okay, so this is one more property when to focus on what. Okay, now as the count of 1 is less than the count of zeros, so I'll be focusing on ones. So how can I get the minimum count from here? How can I get the minimum swaps from here? Can I simply count the maximum number of ones occurring in a string? So in this, the maximum number of ones is 1, max number of ones is 1, max number of twos are, max number of ones is 2 here. So in S3, we are getting the maximum count. So can I simply get the minimum number of operations as C1 minus maximum ones? Only if it is falling under this case, right? It's 4 minus 2 will be 2. So 2 will be the output for this. 2 will be the output for this. We'll understand this logic once you do on this. Now, here the value of C0 is 4, the value of C1 is 8. We need minimum number of operations. So, can I simply, first what I'll do is I'll check, are these values divisible by 4 or not? Yes, these are. Yes, these are divisible by 4. So, I'll be focusing on this condition next. Is C1 less than C0? No, but C0 is less than C1. So, what will be my minimum value? It's C0 minus maximum zeros in the string. So here the max zeros are 1, here the max zeros are 1, here the zeros are 2. So the maximum zeros in a single string is 2. So I'll simply print what? Count of zeros, which is 4 minus 2 is 2 again. So here the minimum number of operations taken is 2. Okay, so let's convert this observation, let's convert this logic into code now. Now let's write code for this. So first we'll be taking test case as input. We'll be iterating for t number of times. Next, let's scan the size of the strings. Next, string S1, S2, S3. Let's take the inputs of 3 strings. Then we'll be taking few variables. One is count of 1 in S1, which is equal to 0 initially. Next, count of 1 in S1 equal to 0. Then C1 S1 is 0. Next, let me copy paste this. Next in C, count of 1 in S2, then count of 1 in S3. Similarly, count of zeros in S equal to 0 initially. Next, count of zeros in S2. Next, count of zeros in S3. So let's start iterating on the string, which is of length S, and let's increment the values according to the condition. So if S1 of I is equal to 1, then you will be incrementing count of 1 in S1. Else you'll be incrementing count of zeros in S1. We'll do the same thing for three different strings. So let me copy paste this and let's change the variables accordingly. So C1 in S2, then C1 in C0 in S2. Let's do it for string 3. So it's C3, count of 1 in 3, count of 0 and 3, CS3. Okay, now once we got this, we should also need a count of total ones. So C1 is equal to C1 in S1 plus C1 in S2 plus C1 in S3. Similarly for 0, C0 is equal to C0 in S1 plus C0 in S2 plus C0 in S3. Now we will be checking if the count of 1 is divisible by the length of string, which is S. So it should be equal to 0, and if count of 1s are divisible by S, then count of zeros will also be divisible by S, but just write the condition of that 0 as well. Now, if count of 1 is less than count of 0, we should be focusing on swapping 1. Okay, so if this is the case, I'll be updating my answer with answer equal to C1 minus maximum of count of 1 in S, comma, maximum of count of 1 in S2, comma, count of 1 in S3. Else my answer will be count of 0 minus maximum of count of 0 in S1, comma, max of count of 0 in S2, comma, count of 0 in S3. At last, I will be printing the value of answer. So if the answer doesn't change, it will remains -1. So answer will be changing only if this is true. Okay, so let's run this and check are we getting the expected output or not. So it will be 1, 1, -1 and 0. So yeah, let's submit this code and see is it passing all the test cases on. Done, we have got the right answer. Even if you remove this condition, if you only check for count of ones, let us submit this again and check. So obviously if count of ones are divisible by s, then count of zeros will also be divisible by s. So instead of checking with count of ones, you can also check it with count of zeros as well. You can solve this problem in other ways as well, but yeah, this is one of the variation to solve this problem. So yeah, this is all about the third problem. Let's move to the next problem. Now coming to the fourth problem, multiplexer. We are given an array A of length n and a positive integer x. You are allowed to perform the following operation to do at most once. So you can choose a subarray of A and multiply each element in that subarray with x. Our task is to determine maximum possible frequency of an element in the array after performing the operation at most for once. The frequency of element is defined as the number of times it appeared in the array. Okay, so the first line of input contains t, which denotes number of test cases. Each test case consists of multiple lines of inputs. So in the first line, in every test case will be n and x, which tells you the size of the array and the number x you need to multiply with. Next line contains n separated with space and integer values, which are array elements. So output format for each test case should be printing a single line, which is nothing but the maximum frequency of any element that can be achieved after performing the operation. So constraints are given, then sample input and output. So yeah, we will be observing how can we solve this problem. Yeah, now coming to this example. So for the first test case, So the size of the array is 2 and the value of x is 1, the value of n is 2 and the array elements are 1, 6. Here if you multiply, if you choose any number and if you multiply it with 1, the value remains same, so the output will be 1. Coming to the next output, 5, 5 and the value of n is 5, the value of x is also 5. So the array elements are 10, 2, 8, 2, 4. So for this, to find the maximum frequency element after multiplying it with 5, if you multiply every number with 5, then you'll be getting 50, 10, then 40, then 10, then 20. Okay, so here the maximum frequency of elements that we can got is 2 for 10. Now if you observe, 10 was already present in the array. So can I select this part of subarray, multiply it with 5, so which results your array as 10, 10, 40, 10 and 4. So if you observe, now we got the output as 3. So the output is 3 here. Next, for this example, it's 4, 3, 6, 2, 6, 2. So if you multiply this part of subarray with 3, the array will be 6, 6, 18 and 6. Now the maximum frequency of an element that we got is 3 here. Okay, so I hope you are clear with the problem statement. Now, so by looking at this pattern, what I can assume is, first what I will be doing is I'll be finding the frequency. So I'll be taking a map. I'll be finding the frequency of every element. So 6 occurred twice, 2 occurred twice. Okay, now what I can do, as of now, I'll be assuming these as my answer, the maximum frequency. Among this, I will be finding the maximum frequency. So as of now, the maximum frequency is 2. And we have 2 such elements in my array, right? If you observe in this example, the map will be looking like 10, 1, 2, 2, 8, 1, 4, 1. Here, the maximum frequency is 2, but the output is not true. The output is not 2. So, can I find the maximum frequency as of now, which is 2? Okay, the maximum frequency is 2, and the element which is having the max frequency is also 2. I'll multiply it with x, which is 5 in this. Okay, once I have multiplied, I'll be getting the value of what? 10. So I will again find how many times does 10 occur in my array from this map again. How many times does 10 occur? Once. So I will be adding plus frequency of that to the max frequency, which gives you 3 as the output. Okay, let's observe this logic on this array. Here, the maximum frequency we got is what? 2. And the elements which are having my max frequency as 2 are 6 and 2. If you multiply 6 with 3 is 18. Do we have 18 in your array? We don't have. Okay, so as of now, my answer will be 2. As of now, my answer will be 2. We will first search, is 18 present in your array? It's not present. So next, I will be applying on the element which is also having max frequency. So I'll be applying 3. So I'll be getting the value as 6. I will check, is 6 present in my array? Yes, it is. But how many times does 6 occur? 2 times. Okay, will you directly add to it? No, we cannot directly add 2 to it. If you directly add 2 to it, you'll be getting 4, which is not correct. Why not? Why it's not correct? Because if I'm considering 2 elements, so this will be my entire subarray. And if you multiply it with 3, you are not getting the correct answer. So from where to where you'll apply 3? See, from here to here you'll be applying 3, so that you'll be getting the array as 6, 18 and 6. So do you understand that we will be finding the position of this in your array, and we will be counting how many times does 6 occurred in between this index and this index. So the value of count here is 1. So it is not 2 plus 2, it is 2 plus 1, which is 3, and which is the correct answer. So yeah, this is the overall observation of the solution. So here, as of now, what did we figure out? We have figured out that first we need to have the maximum frequency. We also want the elements in the array which are having the frequency as the max frequency. Okay. As of now, we have figured out this. Okay. After this, what should I do? I will iterate. Let's say I'll be storing all these elements in one vector. Okay, I'll be iterating on this vector. I will be iterating on this vector, and I will be checking if, let's say, the element into x. We will first check if it is present in my array or not. If it is not present, then nothing to do with that element. We will skip. If it is not present, we will do something if it is present. Now let's see what to do if the element into x is present in your array. Okay, now let's solve this step by step. First, let us take an example. Let's say the array elements you have is 2, 3, 3, 6, 2 here, and 6 here, and 12. Okay, let me write the indices 0, 1, 2, 3, 4, 5, 6. So the first step, let us find the frequencies of every element. So your frequency or your map will be 2 occurred twice, right? Then 3 occurred twice, 6 occurred twice, 12 occurred once. This will be your frequency here. Next, we also need the positions from where to where that particular element has been occurred. So let's take a position. Let's say this is a vector of type integer, and here we need to store the first and last occurrence. So this will be of type pair. So yeah, let's say we have an integer first two, and the pairs are index 0 and index 4. This is one of the value in your position. Next 3 initially occurred at index 1, next last occurrence is at index 2, next 6 initially occurred at index 3, next index 5, next 12 occurred only at index 1, sorry, index 6. So yeah, this is the position array. Now let us also have the hold of maximum count or maximum frequency. So maximum frequency that we got as of now is what? 2. Okay, let's store this as well. Now after completing all this, what I'll do is I will be checking if the value of x is 1. If value of x is 1, I can simply print max count, because if you multiply any value with 1, it remains same. So you simply print maximum count. Yeah, if this is not the case, what I will be doing is I'll be start iterating on this position array. So what I'll do is I will start iterating on the position array using for each loop. So for auto element in the position, what I will do is I will get the first element. Let's say int y is equal to element dot first. Okay, this is a pair, and this is a pair. So the vector is of type pair of int comma pair of int comma. Okay, now I'll be iterating. First I'll be getting the first element of the pair. Now I will be checking frequency of y as y into x. First I will check if that frequency of y is present in your array or not. If it is not present, then you can skip, or you can just write a continue keyword. Nothing to do with that particular element in the array. Okay, but if it is present, what will you do? If it is present, what I'll do is I will simply find the indices. So what I'll do is I'll be taking one more array. I'll be taking one more array, or basically a vector, in which I will be storing, let's say for 2, if you are starting from 2, and the value of x that we have taken is also, let's say the value of x is also 2. So first you will iterate on this. So 2 into 2 will be 4. 4 is not present, so let us skip this. Let us skip this. Next, the element is 3. So 3 into x, which is 3 into 2, is 6. 6 present? Yes, 6 is present. 6 is present. So what I will be doing? What I will be doing? I am iterating on the position array. So if 3 is present, I will be storing the first index of 3, which is 1. Also, I will be storing the last index of 3, which is 2. Also, I will be storing the first index of 6, which is 3 comma 5. But how can I differentiate that this belongs to 3, this belongs to 3, and this belongs to 6, and this belongs to 6? So 3 is the element which I am iterating on the position array. 3 is the element which I am iterating on the position array. But 6 is the element in which I am multiplying it with x. So I should be making somehow difference between this. So what I will be doing is I will be also taking a pair here, in which I will maintain the first index, and if this is the element present in position, I will mark it as +1. You'll understand why to mark it as +1 if you move forward in the solution. Next, this index also belongs to 3, so I'll be maintaining it as +1. Now this doesn't belong to 3, whereas it belongs to 3 into x. So I'll be denoting it as -1. Then the next index of 6 is 5, and we'll represent it with -1. Once we got this, let's say this is an array called merge array. Now what I will be doing is I need to get the subsequence. I need to get the subsequence. So what I do is I'll be sort this based on indices. Sort the above array merge based on indices. So if I sort this, if you observe, the order was already in this sorted orders, but anyhow I'll be getting the same data again even after sorting. So don't get confused. This is the index of 3 which is present in the array, and this is the index of 3 into x, and the value of x is 2. Okay, once I got this, is there any optimal algorithm which gives you maximum subarray? Yes, it is cadence algorithm. And what I will do, I'll simply apply cadence on this sorted data. Simply apply cadence on the sorted data. That's it. This is the entire logic. So let me brief it up. So first, what I'll do is I'll be taking the input. Next, I'll be populating the map to store the frequency and to get the max count or maximum frequency. And I'll be taking a position which is of type pair of pairs. In this, I will be storing the elements of the array and the first occurrence and the last occurrence. Same here, element of the array and the first occurrence and the last occurrence, and so on. Next, I will check the value of x is 1. If the value of x is 1, no matter how many times you multiply, the value of that element remains same. So I'll simply print max count. Okay, if this is not the case, I'll proceed with this entire approach. Okay, so let's convert this logic into code. So let's see how the code will look like. First, we'll be reading the test cases, then we'll be iterating for t number of times. Next, I'll be taking the value of n and x. Then I'll be taking a vector. So as you see, one is for finding the frequencies. Next, this is for the maintaining a pair of pair basically map stores key value pair. So in integer, I will be maintaining that element, and in vector, I'll be maintaining the indices of that. Okay, so basically it is a of I comma indices at which the a of I will occur, and also having a maximum count to store the maximum frequency. Okay, let's start iterating on the array. So from int I equal to 0, I less than n, we'll be taking the array value here. At the same time, I'll be updating the frequency of that particular element. Then I also update the position array. If you observe, position of a of I, so a of ith element with the ith index. Okay, next max count will, here itself will be updating the maximum count with max of max count comma frequency of that particular element in your array. Now, as I told you, first I will be checking for the value of x as 1. If the value of x is 1, no matter how many times you multiply, the value remains same. So I'll be directly printing the max count, and I'll be writing the continue keyword. That means if this is true, then no need to check this entire iteration. Just skip that iteration and continue for the next iteration. Now coming to the next part, if this is not true, I'll simply iterate on the position array. Okay, I'll be iterating on the position array, and the position array is of type pairs. So first, I'll be accessing the first value of that pair by element dot first, and I'll be storing it in the value. Next, I'll be finding the value into x, and I'll be storing it in a variable called y. First, I will check if that value is present in your array or not. If it is not present, according to the cadence algorithm logic that we have saw, I'll be simply skipping that particular iteration, and I'll be saying that you continue with the next iteration. Okay, next. If that element is present, I'll be finding what is the frequency of value into x. Okay, next. Now coming to this merged array logic, I'll be declaring a merged array first. Then I'll be iterating on that vector. So basically, element dot second gives you the vector. If you observe here, this is the first value and this is the second value. Okay, so which is nothing but a vector actually. So we'll be iterating on element dot second. We are iterating on element dot second, which is basically a vector. Next, I'll be pushing back that particular idx, and if that is the element that we are taking, we'll be representing it as 1. Okay, now next we are searching for what? Position of y. So what is the difference between this y? Y is nothing but multiplied value. Y is nothing but a multiplied value. So as we saw in the logic, I'll be representing that multiplied value with -1 and the element value with 1s. Okay, so this line of code tells you that populating the merged array. Next, yes, we'll be sorting this. Next, we'll be taking two variables. One is best sum and current sum. So basically, what are we doing here? We are just applying the cadence algorithm. That's it. We're applying the cadence algorithm and getting the best sum on that particular element. Next, I'm updating the maximum count with max of max count plus frequency of y plus best sum. Okay, we will be doing this process for all the elements present in your position array or a position map. And at last, we'll be printing the maximum count. Okay, so let's run this code and let's check are we getting the expected output or not, which is 1, 3, 3 and 2. Okay, we got the output. Let's submit the code. Done. Yeah, we are able to pass all the test cases. So yeah, this is all about the fourth problem. So if you observe from problem 1, the difficulty level goes on increasing.
So yeah, that's it from this video. If you like the content, make sure to like the video and subscribe to our Smart Interviews YouTube channel so that you will never miss an update from us. Thank you. Bye everyone.